talking about today. I'll give you a very high-level overview of the ENVI software. Sky's going to talk a little bit about the Airbus DS constellation. We're really going to focus on some field-level analytics and working at the field level in this event, as opposed to working with a large single image. So I think this should be relevant to a lot of people who are interested in one particular crop or a certain area. And then we're going to have a special promotion at the end for allowing people to get some data and analysis from us, and I'll explain that at the end. So just to give you a little overview of the ENVI Stack, we have the ENVI image analysis software. This is a full-featured remote sensing toolkit that it has extensibility with ArcGIS, also with the IDL software. IDL is a programming language, and ENVI is written in that. And all of this can be deployed to the cloud via the ENVI Services Engine or the Geospatial framework. We also have a consulting group that provides extensibility to ENVI and IDL and allows you to customize the tool and create specific products for your needs. We employ a staff of scientists and mathematicians, people who are really smart in solving hard imagery problems, and that's when people come to us for consulting services. So ENVI is used across a multitude of industries and has been around since the early 90s. Obviously agriculture, what we're talking about here, but also forest management, defense and intelligence, disaster response, asset management, obviously university and governmental research, even medical imaging. Pretty much any kind of imagery that you can work with, you can analyze inside the ENVI software. So it's a robust suite of tools for getting the most analytics out of your data. So some of the data types we support: multispectral, hyperspectral, thermal, synthetic aperture radar, elevation, and LiDAR data. And one of the features we added recently in ENVI in the orthorectification package is the ability to derive 3D point clouds from stereo paired data. And this is something that you can take advantage of. Airbus is stereo data from the Pléiades sensor and also SPOT. So I just wanted to mention that, since that's a relatively new feature. We're not going to go into that today, but certainly if you have questions about that, I can answer those, or Sky can answer those at a later time. So just some of the analytic capabilities inside of ENVI. They include image classification, object-based feature extraction, so being able to work with a group of pixels as opposed to a single pixel to derive a classification, target detection, material identification, change detection. And all of these analytics are deployable to a cloud environment. So you could put them up on AWS, you can develop a web interface, and have people search and discover data, and then be able to run any of these analytics that they would like in a cloud-based environment. Or if you're working with a large amount of data, create a turnkey system such that you're getting results as opposed to clicking again and again and again to get what you want. So it's a very powerful suite of tools for working with imagery. And now I'll turn it over to Sky.
Thank you, Amanda. So the first thing we'll talk about is satellite imagery. Airbus Defense and Space is very well known for optical and radar, providing multi-resolution solutions anywhere from 50 centimeter up to 40 meter, depending on which sensor you're talking about. And I'll go through more of these bullets a little bit later on. You can go ahead and click to the next one, please, Amanda. We have the capability to produce mosaics, DEMs, digital elevation models. One of our turnkey products is the World DEM, and then also going on to the next one here, geospatial solutions. So a lot of customers are currently asking us for much more than just pixels. And working with Harris, we really have the ability to provide what we would call actionable intelligence and actually take imagery through a variety of steps, whether it's orthorectification, atmospheric correction, applying different algorithms that we'll show later on, and actually delivering something that is pre-processed to a point where a customer can just use it in the field or take it to their agronomy team and go from there. So there really are a lot of options working with both Airbus and Harris, and it's much more than just buying data and processing on your side if you're looking for that type of capability. And please go on to the next slide. Thanks, Amanda. We have an overview of the constellation here. Pléiades is very well known. It's our high-resolution system. The nice thing about our constellation is that we basically have 4 sets of twins. It truly is a real constellation. These are identical satellites. Pléiades 1A, 1B, they're twins, same with Spot 6 and 7, and same on the radar side. There's capabilities here to use satellites to collect anywhere from 50 centimeter to 6.5 meter And on the far right, I want to introduce a new system which is called CAS-EOSat-1 and CAS-EOSat-2. The great thing about these satellites is that Airbus Defense and Space built them for KGS, which is a group in Kazakhstan. We have an agreement with KGS that allows Airbus Defense and Space to be the commercial provider for CAS-EOSat-1 and 2, especially in North America. And the nice thing about CAS-EOSat-2 is that it's very, very similar to a RapidEye type satellite. It has 6.5 meter resolution, it has red edge, and it has large collection capability as well. So when we talk about setting up a monitoring program for an agricultural application, it's not just using Pléiades or SPOT or CAS. We can really, and I'll talk a little bit more about this later on, but we can really deploy the entire constellation to ensure that we're collecting at the frequency the customers need. So if you're looking for daily, weekly, monthly, there really are a lot of options. And the only other thing I'll say about TerraSAR-X and TandemX is that if you have an application that you would like to test with radar, if you have some interesting ideas regarding using radar for agriculture, please contact me. I would love to talk about that. So far, I've seen a few companies use radar for monitoring irrigated rice fields and a few very specific applications, but we're always open to talking with you and potentially providing some sample data for testing. So if there's any ideas there, please contact me after the webinar. And you can go on to the next slide next. Put this up just to show you some acquisition modes on Pléiades and just to once again reinforce the capability and the accuracy of this satellite. We have the ability to collect many different AOIs in a single pass, and it's not just about collecting a large area every single time, every single day. We really are targeted around what our customers are asking us to collect. There's different acquisition modes, anywhere from stereo to multi-targets, corridor acquisition, but just the overall point here is that you can give us your field level boundaries and we can work on our side to make sure the satellites collect them at the right time and using the right satellite. You can go on to the next slide. Thank you.
Okay, thanks, Sky. So what we're going to explain now, or what I'm going to explain now, is the workflow that we use to get to some field level analytics. And basically what we did is Airbus very kindly provided us with some Pléiades data in the Imperial Valley of California. And so you can see the whole image there on the right, and obviously there are many fields there. Each one of those fields represents a unique opportunity for providing analysis. You know, in the past I think we really focused on providing image level analytics, but in more people that I talk to, it seems like growers are interested in their field. Certain markets and industries like insurance are interested in a specific crop or commodity. And so this webinar is a little bit more focused in getting information at that field level. In spite of that, you still need to perform some basic pre-processing steps, whether you're working at the field or the image level. And those steps are performing radiometric calibration, and basically you do that with the Pléiades data. ENVI ingests all the coefficients to do so. It's very simple. Pan sharpen the data. This makes the data, the 2-meter multispectral Pléiades imagery, sharpened at the 50 centimeter panchromatic level, so you ultimately end up with a 50 centimeter multispectral image. And the algorithm we use in ENVI, that I use today, is called NN-Diffuse. Many of you might be familiar with Graham-Schmidt spectral sharpening, which also is a very good algorithm. NN-Diffuse is relatively new and reduces some of the pixel bleed over that you might see with other algorithms. So you end up with a really nice product for analysis going forward after that step. And then we perform an orthorectification using the RPC data that comes with the Airbus DS imagery. And basically that's taking into account the effect of terrain and correcting the imagery such that you know you're getting the exact point on the ground. And that's really important if you're working with another GIS so that you can get accurate information and extract accurate data. And then after that we do the quick atmospheric correction that removes additional atmospheric effects such as water vapor, aerosols, that type of thing, so that you're getting really a crisp image to work with, and you're also getting something comparable. So let's say if you're working with a field over time, if you atmospherically correct, you're more likely to get better results over time and being able to have a comparable image. And then we also have a data discovery piece. And basically everything here, with the exception of that data discovery, can be automated into a turnkey system. So if you're working with one image or, you know, 100 fields, 1,000 fields, you can automate all of these processes so you can click once and get a result. And the data discovery piece is something you really should do at the start of your analysis process. And while that's not necessarily something to be automated, it's an important step. And once you find some information about your imagery, you don't necessarily have to repeat it for every data set because you know the best way to go forward. So let's talk a little bit about field level analytics. So this is obviously way zoomed in on that Pléiades image. And the field here, I don't know what this area is. I have no idea what that crop is. What if you're a researcher and you're trying to learn something about a particular crop like grapes or rice, and you're trying to find where all of those crops exist? So that's when something like USDA's cropland data layer comes in. So this is a system called Cropscape. It's freely available data. It's continental-wide. It's updated annually, and basically it's a classification result that shows you what each field is in the continental United States. I'm not sure if something like this exists internationally, or I'm sure for certain countries there is a product, but for the United States this is an excellent tool generated by the USDA. It doesn't take into account crop rotation necessarily. I mean, you could say in certain areas you know that there's going to be a rotation between like maybe corn and milo or something like that. But for fixed crops or permanent crops, it doesn't necessarily matter because you're obviously not going to rotate your citrus crop every year. It's a tree that grows for a long time. This tool really gives you a good idea of what is likely to be there, and it's a great start if you don't have any prior knowledge working with a certain area. So here's what this looks like at the continental scale, and there's several ways you can get data: by county, by state, by your area of interest. You can perform change detection because this is a historic product, and the data come as KML or TIFF. So there's, you could take that whole TIFF for the United States and do a change detection and find out how crops change from one year to another. So this is a really great product. And let's see my animation. So zoomed out, the data they look pretty good. It looks like it's a very nice data set. And then once you zoom in, you're getting that field level analysis, and you can clearly see defined fields. But once you zoom in a little bit more, you start to see that it's a little bit pixelated, and that's because this is based off of Landsat imagery. So ultimately, it's an approximate result. It's a classification, but USDA has worked very hard to get a high level of accuracy with this product, and it's really, quite frankly, the best thing out there. And so I'll show you how we're going to use it in just a moment, but I'm going to have Sky talk a little bit more about some of the Airbus DS capabilities for monitoring.
Thank you, Amanda. So on the top here we have very high resolution agricultural monitoring and 50 centimeters to 2 meters, because the majority of the work that we have done in the past 2 ag seasons have been with Pléiades 1A and 1B. We now have the opportunity to use CasioSat-1, which is 1 meter pan and 4 meter multispectral, and that gives us just another tool within our toolbox to basically increase the frequency of collections. With 1A and 1B, say you're trying to collect an area in the Central Valley of California, we basically have 4 potential attempts per week at a pretty restricted incidence angle. If we add in CAS as well, then we can get to a point where we have 5 or 6 potential attempts per week. And with areas that have relatively good weather, it's pretty easy to collect the right data at the right time. If we're looking at a different type of crop, maybe we're looking at corn or something else in the Midwest, for example, it's not really necessary to use a 50 centimeter satellite. And as some of the areas of interest are quite large, it really can be more efficient to use a spot type satellite. With Spot 6 and Spot 7, we have 1.5 meter panchromatic and 6 meter multispectral, and we have red, green, blue, and near-infrared 1, which are key bands. With CasioSat-2, we also have red edge, and we also have a wide swath of 77 kilometers. So once again, we can use these 3 satellites as a true constellation to monitor areas of interest, not just in the Midwest United States, obviously around the world, and really can collect anywhere at any time, almost daily. So this constellation really gives us a lot of capability for precision ag, and the nice thing about this system overall is that with Pléiades, 95% of the capacity is dedicated to the commercial market, and with Spot 6 and 7, it truly is 100%. We own these satellites, we built these satellites, they're tools that we use daily. We have programming teams around the world that can be very reactive, and they're systems that just work really well for ag. You can go through the 2 statements on the bottom, but it's basically what I just summarized. We use this as a constellation. It's not just about using one of the satellites. If you have a specific type of crop and you really require Pléiades only or CAS only, that's something we absolutely can talk about. And if you're looking to really set up intensive monitoring, it is possible to set up all 6 satellites into a single program. when I have 25 to 100 square kilometers, that's just targeted areas for Pléiades, typically around very high-value crops in California, such as almonds and some of the citrus crops. But obviously, other parts of the country, we're collecting areas that are significantly larger than that with spot and with cause. So I will stop there on this slide, and you can go on to the next one. Thanks, Amanda.
Yeah. Thanks, Guy. And just to emphasize here, and this is not just because Airbus sent me a giant chocolate bar at Christmas time, they've been absolutely amazing to work with as far as flexibility with tasking, and the customers that I've worked with. It's very easy to task these systems and get results, and they're a great team to work with. So I've been totally impressed with them. Their GeoStores are really an easy interface to work with. And just a comment here, there is a tool on our ENVI extensions page that you can actually browse their GeoStore from within inside of ENVI. So that's certainly an option, and if you have questions about getting that, you can email Sky or myself. So, next slide. So we talked a little bit about the pre-processing, and so now I want to dive into that data animation or data discovery bit. So basically what we did is we found that field with the CDL data. So let's explore a little bit more about that. In ENVI, you can compute a number of vegetation indices, and essentially that the different vegetation indices tell you a lot about the data that you have. And I'm going to start this animation, and one of the things to notice here is the indices, different ones show very different results. And it's not always that an NDVI or OSAVI or MSAVI is really going to be the best one for you. And so that's where this data discovery piece really comes in. And one of the things I want to call out here is ultimately we'll discover that this is a vineyard. And you can see here that you have this kind of like bright area that's showing very healthy vegetation. And ultimately we can see that this is probably some weeds growing in between the rows here, if you can see me mousing around on the right. And that's not necessarily the healthiest part of your field. And so that actually, you could use that information to help you find weeds in the case of row crops where you see something growing in between the different crops or the different rows. And then also with doing this type of animation, you can see that there's certain indices that really saturate and don't tell you much of anything at all. And if we go back to the green atmospherically resistance index, this is the one that I actually liked the most, that I thought it told me a lot about where I had really healthy plants, where I had things in decline. I have a good kind of definition of each plant, which is an important feature going into the plant counter that I'll talk about in just a second. But it's this type of data discovery, being able to animate through the different vegetation indices that allow me to discover that bit of information, that it's not always the common indices that are going to be best for you. So let me introduce the ENVI Toolkit for Precision Agriculture. So basically this is a group of libraries that will create precision agriculture products, and this can be in an enterprise or turnkey environment. So you can think of this as an API into ENVI for creating precision agriculture products. This provides some workflow support, so there's the initial pre-processing steps that you can choose to do. There's the capability to delegate tasks to workers for a higher throughput. It computes these various vegetation indices and will appropriately look at your data for the bands that you have and suggest which indices are going to actually work for that, because obviously there's different indices can be computed for Landsat data, let's say, than there can for Pléiades multispectral data, just because there's different number of bands. This includes a plant counting tool, and I'll talk about how resolution is really important for that. And then there's a hotspot analysis that uses the GEDIS.org spatial statistic. I included the link there to the original paper from 1992. So this is a tried and true method for deriving a kind of a spatial statistic showing where you have healthier or less healthy areas in your field. It's basically showing statistical extrema. And you could use that perhaps for additional like prescription or prescriptive agriculture work. This is an add-on module to ENVI or ESE. And then the last piece is report generation. You can get a PDF report out of the different tools from either plant counting or vegetation indices, and I'll go through that as well. So here we have the interface, and this is kind of like a helper interface. Again, this is a library, and it's more intended to be run in a background or a command interface. But if you're working on debugging, you know, the workflow I use to generate these products in ENVI were essentially to do the pre-processing in ENVI, to find that best workflow, do the data discovery, and then once I got to that point of going, okay, this atmospherically resistant index works really well, that's when I go over into this interface and I kind of walk through it once and go, okay, everything works, now let me automate it. And you can see down here, it gives you a list of the jobs that you've submitted. You can review any reports or errors that you get. So there's some nice functionality here for getting started. But generally the intent is that this would be a toolkit that would plug into ENVI Desktop or the ENVI Services engine for more processing either large data sets or creating a web interface for somebody else to submit jobs to create products. So let's look at the plant counter. So the plant counter is going to allow us to count plants within a field. And so the key thing here is you're going to be submitting fields to this algorithm. You're not submitting the whole image because fields have different level of spacing of plants. And so what this is doing is it's using kind of an algorithm to find edges and roundness and features to try to find individual plants. And you can see here in this circled area some inputs that you need to provide. So is there overlapping canopies? Is there a space between the canopies? There's no overlap, then you would enter 0. In the search bounds, this is where that data discovery piece again came in, is basically I counted how large a plant was. Like I looked at the smallest one and said, well, that's 4 pixels across, and then the largest one was about 12 pixels across, and let me step through it every 1 pixel. And it also gives you an option to submit a tile size. So if you're working with a very large field or something like that, like very high resolution data like UAS, you might want to adjust that. For the field level data that I was working with Pléiades, I didn't need to do anything like that. But it gives you some parameters that you do need to set because otherwise the algorithm wouldn't necessarily find all the things you wanted to find. So let me give you some examples of good and bad fields for plant counting. You can see the top ones are both images that I can clearly see the plant boundaries. If I were to sit there and try to put a dot on each one of those plants, I'd be going blind and pulling out my hair because there's hundreds of plants in those fields, perhaps thousands. But with the plant counter, you get a result in literally seconds on the number of plants within a field, and you could then correlate that back to yield. You could correlate that to a growth stage, and so it's a pretty unique tool. And you can see in the lower views that basically those crops you can't necessarily see the resolution of the plant. Those are probably maybe beans or lettuces. So using the Pléiades data, you can get to, I would say, twice the resolution of the pixel. So we pan sharpened it to 50 centimeters. If you have a plant that is 1 meter across, I'd say you have a shot, but I'd probably want to look at the data. It'd probably be better to have 2 or 3 pixels on top of a crown to really define it. So something very small like a head of lettuce isn't necessarily going to work with this, but there's certainly a number of crops that would. So here's the result using that atmospherically resistant vegetation index. And by the way, with the CDL data, we were able to determine this field is a grape vineyard. And basically, what I did here was I counted the plants that it missed. Obviously, if I'm going to try to count all the plants that it hit, I'm going to be counting for a while. So what I did was I counted the misses, I added that with the plants found, which was 778, and then I got an overall accuracy of about 95%. And typically with classifiers, getting anything higher than 95% is really, really good. Because even the human eye, I was looking at some of these and I'm like, I wouldn't have pulled that out as a plant crown, but now that I see the circle around it, yeah, I see how that's a plant. So it's a very good result, and we're pretty excited about this tool for being able to do crop counting. And so here's the report that it generates. You can get the center, latitude, and longitude. You get a little scale bar. You get the count and the date that it was created. And this just comes out in a PDF. Certainly, if you'd like some customization, there's the services team is happy to provide that if you need to have it customized for your own product, but this is the generalized output. And then a little bit more on our hotspot tools. So again, this is used the GetASORD spatial statistic, and so it creates basically a spatial heat map of higher or lower statistical values. And initially, just looking at the CIR image, like I can see, okay, this area looks a little bit healthier, this looks, yeah, a little bit healthier. And from the VI, I get kind of that sense as well. But actually, when I start looking at this hotspot, it does start guiding my eye to areas of the field that are less healthy than the others. And so if I was spraying fertilizer or watering, I could use that as an additional input, use that output in a shapefile, perhaps even load up information into a sprayer or a fertilizer so that I would know where to spend more time on the field that I'm working with. And again, this is a numeric algorithm, so it's really looking for statistical extrema, and it's really, that's where you have to have kind of that smarts about it to know, okay, well that's extreme, is that good or bad? What does that mean for my field? So having some knowledge about the imagery and the site that you're working with if you're going to be making a prescription is important. And so as I mentioned, all of these tools can be used in the enterprise, and it can be made turnkey and deployed to the cloud. So you could think of something like an AWS instance. You have your data residing there. You install ENVI or ESE in this library there, and you could point it towards, you know, if you have 1,000 fields in your area of interest, point it towards analyzing those 1,000 fields and getting a result. You know, that data exploration piece is really important, but once you figure out the best VIs for your specific crop, you don't necessarily have to repeat that step. And, you know, and the availability of affordable Airbus data in season makes work like this really possible. Certainly not being able to get imagery frequently, or if you're having a problem tasking, you're not going to be able to do this type of analytics that are fast, that are effective. And it's been, you know, working on this webinar really opened my eyes about working at the field level and how easy it is really to get data and then produce the analysis. So to summarize, we have the ENVI Toolkit for Precision Agriculture is now, well, it's actually not now available. I'm so used to saying that. We're still doing some of the final QA and QC, and we're looking to have it available later in May. And basically this is a tool, it's a library that you can use to tune to extract information that you can drive yield, health, or make a crop prediction or prescription. And the Airbus DS organization provides excellent data for field level analytics and has very flexible and affording tasking options. And Sky can certainly answer more questions on that. So now for the promotion that you've all been waiting for. So the first 20 people to reach out to us at geospatialinfo@harris.com will receive a plant count or a VI analysis on a field of their choice. So basically, you send us a shapefile of one field. Airbus DS will provide imagery back to Harris, and then we will, again, if you have imagery or you have a field that's at that low, or the crop you're looking for is very small, we'll just provide you with a vegetation analysis. And if you do have a crop or a field that the plants are very distinct, we can provide you with a plant counting analysis. So certainly, if you would like to reach out to us on that, we're happy to provide that to you. So at this point, we'll turn it over to questions. We have our contact details if you'd like to reach out and ask us directly. But Kevin, are there any questions that you've seen in the question panel that you'd like to call out?
Yeah, definitely. Thank you very much, Sky and Amanda, for your informative presentations. At this point, as Amanda just mentioned, she and Sky will try to address as many questions as they can that have come in. And as a reminder, if you have a question, feel free to type it into the questions part of the dashboard, and we'll try to get to as many of them as we can. So with that, oh, and I guess before we jump to questions, I'll mention a recording of the webinar will be sent to attendees in a few days, and the recording will also be made available on the Harris Geospatial website and the Airbus Defense and Space website. So that if you want to share with colleagues or want to refer back to it, you have access to that. So there are a ton of questions that come in. Let's just start with the first that I see. Sky, this one's probably for you. How quickly can Airbus Defense and Space deliver imagery to its customers after acquisition?
Thank you, Kevin. It's a good question. I mean, with precision agriculture, it really is becoming more about delivering data in near real time. And with Pléiades and with Spot, we have rush delivery options, and we're working on those with the COS satellites as well. But I've worked on some projects where we have delivered imagery same day, and sometimes within 4 to 6 hours of acquisition, and then have processed that imagery same day so that we can deliver reports to the customer same day or early the following day so that they can plan for their activities as soon as possible. And obviously the newer the data is, the better. So that's really, speed is really of the essence.
Great. The next question I think is for Amanda. Do I need other tools to run the ENVI Precision Agricultural Toolkit?
Yes, you do. So if you want to do the atmospheric correction, you need the atmospheric correction module. Obviously, this is a plug-in to ENVI or the ENVI Services Engine, so you need that as a baseline package. So yeah, you'd need ENVI or ESE, and if you wanted to do atmospheric correction, you'd need the atmospheric correction module that contains Flash and Quack.
All right. Next question. Can we estimate mineral resources such as phosphate, uranium, etc.?
There are other tools inside of ENVI that you would use for that type of analysis. There are indices that look for specific nutrients, but you'd have to probably work with different imagery. It depends on the minerals you're looking for, but that's probably a more in-depth question than the time for this one would allow.
Yeah, I think, Amanda, that's a great answer, and if we can talk more in detail about that, if someone would like to email either one of us, I'd be happy to talk about that.
What is the accuracy of the orthorectification? Is it only a few meters, pixels, etc.?
So I will answer that one. There really are quite a few options with orthorectification, and if you're going to be comparing imagery throughout the season, especially say 5, 10, 15 images, having consistent accuracy is really important, and making sure that you have a process that will take the imagery and align each pixel with the previous pixel, because if you're having some type of shift and then you're processing that imagery, you're not really going to be able to compare throughout the growing season. So we have different options when it comes to orthorectification, and some of the processes that I've mentioned can do very advanced orthorectification that will match to a customer's existing imagery data set, or potentially we can also work with ground control points or whatever is necessary to achieve exactly the type of accuracy that's required. We've taken some Pléiades data and orthorectified it to sub-meter level using some very basic data. So there really are quite a few options, and it really, when we talk about ortho accuracy, that's when we really start talking about custom applications and custom programs with Harris.
Yeah, and just to chime in, so ENVI out of the box comes with a standard RPC orthorectification, and then there is an orthorectification module that does a very high precision orthorectification, so it allows you to do block bundle adjustment and provide your own ground control points. So it takes advantage of kind of additional information and that is provided by the user.
Very good. Can you link imagery with fertilizer demand and also food production?
Certainly. You can look at areas that are less healthy in your field and add more fertilizer to that region. Again, that depends on you knowing something about the crop that you're growing and the amount of fertilizer you typically provide, but it would allow you to use less in areas that are healthy and use more in areas that are less healthy. So it depends on having the right equipment. And then as far as food supply, certainly you can use indices or plant counting to correlate to yield. And so if you're growing a food-based crop, you could correlate that, but you would need some historic data like such as previous yields, and probably multi-temporal data would help get a more accurate result with that.
The next question is, can Airbus provide data by AOI rather than image seen?
So the answer to that is absolutely yes. We have the capability to produce down to very small AOIs, and they can be just a few square kilometers. And most of the work we do with Precision Ag clients is targeted around specific AOIs that are somewhere in the 10 to 100 square kilometer range. And then within those AOIs, there's obviously many different fields. But yes, we can be very targeted, and it's not like the old Spot 5 days and Spot 4 days where customers were forced to buy an entire scene, which was a few thousand square kilometers and very inefficient for agriculture.
The next question, Sky, I think it's for you. How much does the superior spatial resolution of Spot 6 and 7 and Pléiades outweigh the benefits of some of the spectral resolution given by other sensors such as Landsat 8 and Sentinel-2 for agricultural monitoring purposes?
That's a really good question, and one point I'd like to point out to start is that Airbus Defense and Space actually built the Sentinel system for ESA, one of our best customers, of course, in Europe. Sentinel has 4 bands that are 10-meter resolution, which are great, and it has a wide swath, and it's collecting a significant amount of data each day. So if you are just looking at maybe doing some large area monitoring or taking a look at some of the medium resolution, as I would call it, data, there's a lot of value there. Same with Landsat 8 at 15 meter, and obviously there's some other bands on Sentinel that go up to 60 meter resolution as well that can do some things that we really cannot, or just we don't have those type of bands on our satellites. But with Pléiades and with Spot, you can achieve a much higher resolution data set, up to 50 centimeter resolution. So obviously if you're looking at a high value crop, if you're trying to count trees or count number of plants within a vineyard, for example, you're not going to be able to achieve that with the lower resolution data. The other thing is that we can collect at a much higher frequency than Landsat and Sentinel and really collect around a very short window of a 2 or 3 day window. With Landsat and Sentinel, you're really stuck in terms of the government programs. So they're very complementary, and most customers I work with are using a combination of our premium data and either Landsat or Sentinel or all of the satellites.
Thank you, Sky. Can you do stand counts of corn, or is that plant too small?
Go ahead, Amanda.
I was going to say it depends on the growth phase of it and how it's planted. So potentially, maybe at the latest stage when the plant is fairly large, you may be able to do it with Pléiades data. That might be a crop where UAS data would need to come in. It could also just be augmented, like augment the Pléiades data to have like a UAS scene to verify. And then once you know that, okay, I know with the higher resolution data I get this result, and with Pléiades I get this result, you can at least kind of calibrate between that. So yeah, that's my answer. Sky?
Yeah, I agree completely with what you just said, and I think that for any type of stand count where currently most companies are using UAS systems and they're flying, or aerial systems and they're flying extremely high resolution, anywhere from 2 to 5 centimeter, if you're trying to do a stand count early, obviously right after you've planted or very early in the growth cycle. So that's the type of resolution that at this time is not available from a satellite. Moving forward, I think Airbus specifically will probably have some systems that are high-altitude UAVs that may be able to achieve this type of resolution in within a year or two. It may not be that far off, but currently there is no provider, any type of remote sensing provider, especially operating out of space, that's going to be able to provide that type of resolution. But combining a UAS flight with Pléiades data would probably correlate the two, and there are some companies that are just starting to do this type of work. So that's a great question, and something that if you want to take a look at some sample data, just send us an AOI, and we'll help make that happen.
Great, thank you. Can ENVI be used in sub-Saharan Africa where fields are highly heterogeneous in plant cover?
You certainly could. You could certainly perform vegetation indices on that data. As far as plant counting, if it's, you've got a mix of, an almond tree next to a blueberry bush, you probably, the way it's designed right now, could not use it because it's looking for consistency in the crop. But if you have data, I'm certainly happy to take a look.
And a related question, can the plant counter be used in a plantation forest environment?
Yes. Again, provided you have that resolution and you can see the crown of the tree, you could certainly use that for a forestry application.
All right. The next question is, can the ENVI Precision Ag Toolkit support other data in addition to Airbus?
Yes. So basically it supports most file formats that ENVI supports and also supports UAS data. So if you have RGB data, even just simple like SLR camera data, you could use the plant counter with that. You're not necessarily going to get great results on the vegetation indices just because it's not calibrated data and you don't necessarily have that many bands, but again, for counting purposes, you can make it work.
Great. Sky, can we use a mix of the satellites at different stages? For example, could we use Pléiades for a base map and then monitor with spot 6 or 7?
Absolutely, yes. And to your previous question, we do have some customers that will approach Airbus and will give us some aerial data. They have typically very high resolution data that's maybe 5 to 10 centimeters or 5 to 20 centimeters. Sometimes it's been flown on a helicopter. That can be used for just a very high quality base map, and from there we will monitor with Pléiades or Spot. So yes, we can set up any type of monitoring at any time with any of the satellites. We have a lot of flexibility, and it's not about trying to fit within our ag program. We're trying to work with companies to make sure that we collect what they need on their schedule. So that's where the flexibility comes in. I probably hope that answers the question.
Next question, I think maybe Amanda, this one might be for you. Do you recommend running a vegetation index after a pan sharpening? Does it distort the vegetation index?
That's a good question because order of operations does matter in remote sensing. What I recommend first again is the radiometric calibration. So basically getting the data to units of radiance. So it's a measurable quantity, and that's basically a unit that you have, like the satellite when it's calibrated on the ground, you convert it over to those units because the bands can be scaled at different factors, and that does impact your vegetation analysis. And I actually experienced that firsthand preparing this webinar when I was trying to do some quick and dirty work, and the plant counter wasn't working, and I'm like, okay, I'm going to do this the right way, go back and radiometrically correct it, and yeah, then everything worked fine. But going back to the pan sharpening question, so the in and diffuse algorithm really preserves the spectral shape of the data, and that's one of the reasons I really like it. So yes, you can run a vegetation index after doing the pan sharpening, and I find you get very good results because again, you get that additional spatial resolution with the data, and you're preserving the spectral content by using that algorithm. So if you're an absolute purist, let's say you're trying to do just exquisite research, trying to correlate a pixel on the ground to a physical factor. For that, I would say don't pan sharpen. And that's kind of like why you don't pan sharpen hyperspectral data very much, is because you don't want to dilute that signal and you want it to be really relatable to a physical meaningful number. But for kind of a qualitative more analysis, like more healthy, less healthy, in my mind that doesn't matter, and pan sharpening is an appropriate step to take.
Great. Amanda, I think the next one might be for you as well. For plant counting of crops, can you only use imagery, or could you also use UAS-derived imagery? And if you can use UAS imagery, how does that need to be sent to you?
So yes, you can use UAS imagery. With UAS data, oftentimes you're taking hundreds of images per field, and you end up with a fairly massive data set. And that data needs to be orthorectified and mosaicked. And there are a couple different packages out there. There's Pix4D. We actually have a promotion now with the One Button software where you can get a free evaluation of it to work with your UAS data. We're going to be doing a webinar on that next month, but you can learn more on our website about that. And basically, what I've seen with One Button is that it mosaics the data very quickly. It's very accurate. It works with more than 4 bands of data. But yes, you do have to do that pre-processing step to have the data mosaic so that it's actually a meaning contiguous image. Otherwise, you just have like tiny little snippets of your field. And yeah, you can count in that region, but it's not going to be, it would just be a subsample of your data. It wouldn't be the entire thing.
Sky or Amanda, I think both of you might be able to answer this. can you perform analysis for larger scale purposes such as commodity tracking?
Yes, Airbus has worked on this type of application actually for quite some time, and through some groups within Europe that were previously called Infoterra, we previously had a product called Crop Forecaster, and I've worked on it specifically. If someone would like to talk about that, it's definitely a little bit different than what we've talked about in this webinar, but please send me an email. We can set up a call and talk about options. There's a lot of capability, especially when you think about using Sentinel and having Airbus and Harris process the data and work to answer those questions. It's definitely a newer application just due to the availability of satellite data now, but that's something I'd love to talk about.
And yeah, just to, I concur, as far as doing wide commodity analyses, I mean, that's one of the reasons that we have this available as a library, such that you could have like literally hundreds of thousands of fields across the country and feed that information into this system to get results. Obviously, there's going to be some of that pre-processing step to make sure you're going to get an accurate result, but the tools are there to create these large-scale products that can give you a lot of information about how a commodity is trending over a season or years, and that could be used by the insurance industry or finance, you name it.
I think just to make one more point on this one is that I didn't really speak a lot about the DMC and the Deimos imagery, but Airbus always, or not always, but typically has had a program the past few years to collect a significant amount of 22 meter over the continental 48 during the growing season for a government application. We can combine that 22 meter data with Landsat or Sentinel data, and you can basically have almost a weekly or a bi-weekly acquisition of the entire lower 48. So if you're trying to monitor the corn crop, for example, that is possible with that type of product. It's just as a custom application we need to talk more about.
Thank you. Next question. Is there a reason you would apply pan sharpening before using Quack?
So again, this is kind of, I'd say it's debatable. You could do it. I find that, again, because of the spectral signature being preserved fairly well in the panchromatic data, you're still removing atmospheric effects. You're just doing it on a higher resolution data is kind of how I think about it. Doing it prior to pan sharpening sometimes can introduce some strange artifacts in some ways, because then you're not really taking into account the panchromatic data in some form. You know, I see, Christy, I see that you asked this question, so I might give you a call later and we can hash this out in a little bit more detail, but you know, that's my preferred order of operation. I know some people probably are going to disagree with me on it, so, but you know, that's the fun thing about remote sensing. There's different ways to go about it.
We've had multiple questions come in for the pricing of both imagery as well as the toolkit. One, I guess, on the imagery side, someone asked, what is the pricing model if I wanted to monitor 5 square kilometers for 6 months?
So that would be a custom application. It's definitely under our minimum order size if you think about just standard tasking. So I would just say, send me an email and we'll talk about it. 5 is about the small size that we can produce within the production system, but it's something that we absolutely would like to talk about and figure out a program that actually fits within a budget. There's a few different ways we can do it, so we just need to talk about the satellite, the collection window, and go from there. So please send me an email and we can talk about it.
And Amanda, I don't know if you can talk to the cost of the ENVI Precision Ag Toolkit.
The cost varies by the amount of workers that you have. So if you're working on a large project, it's going to be a little bit different than if you're working on a smaller project. So similar to Sky, I would say let's talk about what you're working on and we can figure out what the pricing is. But I would say this, at this point, in my opinion, it's a very affordable solution for the products it provides.
Has the ENVI Toolkit been tested on higher resolution UAV imagery?
Yes, we have had a couple of sample data sets come through, and it does quite well. The main difference, I think, in processing relative to working with the satellite data is UAS data is very high resolution, you know, sometimes on the order of centimeters, and because of that, the processing typically takes longer just because you have more pixels. Certainly if you're working with like a large, like fixed crop, like let's say, or forest or something like that, like pine trees, you could probably resample the data so you don't have quite as many pixels, but you still have enough to define that plant crown. But yeah, I've seen really good results from UAS data.
All right. When deploying to the cloud, can you still maintain manual inputs to the process, such as screen digitizing?
Yes, you can. I've seen that done in another program where basically you can click on the different corners of your field and basically submit that as your job. And that's something that typically you'd be developing in like an HTML5 interface. And we've got some examples. If the person who asked that wants to send me an email, I can send them a link showing that example, and then you can show the source code on the demo page, and you can see kind of how that gets done.
One question that's come in is, what would you consider to be an optimal temporal sampling rate for crop monitoring applications?
It depends on the crop, of course, but from what I've seen for most of the high-value crops, trying to collect once every 7 to 10 days is typically ideal. That's very achievable with Pléiades or Spot. And for some of the other applications, customers are asking for 2 images a month, 1 image a month. It really just depends on where you are and also the type of, I guess, the ability you have to make in-season adjustments on your end. And if you're talking about irrigation monitoring, it can be a lot different. We have customers that are asking us for a much higher frequency in terms of collecting, say, every 3 to 4 days or every 2 to 3 days. So it really is extremely variable. That's where the flexibility comes in, and having a true constellation of satellites that have capacity for this type of work, and a company that, like Airbus, that actually wants to collect for the ag market really comes into play.
Next question, I think for Amanda. How does one access the Precision Agriculture Library?
So we haven't released it yet. We'll be releasing it in the May timeframe. So I would say send me a note, and we'll make sure that once we have it up, that we get in contact with you, and we'll source your solution and get you a quote.
And Sky, I think this one is for you. Now that Sentinel 1A is available and 1B will launch soon, is there any plan to take into account radar imagery and precision agriculture?
That's another great question. I've seen a few companies doing a little bit of R&D regarding around radar, specifically using some of our TerraSAR-X data. They have been reading up on, of course, the Sentinel data, and absolutely are going to be doing some work with it. I think it'll typically have to do, as I mentioned before, with irrigated rice fields in areas that have a very high overall percentage of cloud cover. If you're trying to do tasking in Southeast Asia, for example, or take a look at some other areas around the world where it's 80 or 90, it's cloudy 80 or 90% of the time, using a SAR satellite would be ideal. Also, I've seen some companies do some research around taking a look at disasters, potentially taking a look at a field after there's been a very bad hailstorm or tornado, for example, and actually identifying the extent of the damage using SAR. And typically after some of those events, it can be cloudy for days on end, and the weather can be it can be poor. Sometimes it's not, customers not able to deploy a UAS system. So it's something, as I mentioned, that's just getting started, but if anyone wants to talk about radar or take a look at some of our sample data for potentially doing any type of this work, we'd love to talk about it.
Great. Next question. Will the Precision Toolkit become a part of ENVI or be a separate module like the atmospheric correction module?
It'll be a separate module like the atmospheric correction module, and we don't have plans to change that at this point. So again, if you want to talk about your specific needs, we can get you some pricing.
Thank you. Sky, can Airbus capture areas of approximately 500,000 square kilometers in 15 to 21 day time frame?
Absolutely yes, depending on the system. With the 22-meter system, we're doing that on a daily basis. If you take a look at what Deimos and DMC are collecting, these satellites have a 600-kilometer wide swath. So if you take a look at the width of Oklahoma, for example, I mean, one image is going to cover the entire state of Oklahoma. It can be thousands of kilometers long. So you can collect, say, 4 or 5 images and collect a few 100,000 square kilometers in a single pass. With Spot and with Pléiades, it's going to take a little bit more time because of the footprints and because of the swath widths. But with Spot, we've collected AOIs in the United States around the corn crop that have been over 1 million square kilometers multiple times within the growing season, maybe not to that exact frequency, and typically it has to do with the weather. when there's cloud cover, obviously during the growing season, it can be a challenge to collect some of the larger areas at that frequency at a high resolution. But Airbus will be working on, of course, additional satellites and improving our constellation over time. I think the capabilities are just going to be truly incredible in the next few years in terms of additional satellites coming onto the market. And then there may be the capability to collect a 500,000 or a million square kilometer AOI on a in terms of a very high frequency. And obviously using satellites that are high quality and can be used for this type of application that have consistent radiometry and high quality optics.
Thank you, Sky. Will plant counting work in a pan image, or is an infrared band really a necessity?
You know, the key thing with the plant counting, and it doesn't really matter what the what data you're inputting, is it's looking for bright features. So it could work with the panchromatic. I've fed it in like just a red band, and it did pretty well. The key thing with it will take an input of a vegetation index, which is a single band, but you get the best results when you have your plants or trees appear as the brightest that they could be. So there's, again, that's where that data discovery piece comes in, but I certainly would try it with panchromatic data. I don't see, I wouldn't hesitate.
And looking at plant health, are you limited to plant species, or is the tool able to calculate values? For example, different pastoral grasses.
No, you're not limited to any plant species. You could look at whatever you want, and for pastoral grasses, obviously the crop counter or plant counter isn't really appropriate, but you could certainly run a vegetation index and have a pretty good idea about the health, and there are algorithms out there to correlate that to biomass.
Great. Is it possible to tell from vegetation index due to fertilizer deficit or pest damage?
Yes. If you see areas of your field that are showing to be less healthy than others, there could be a number of things that are wrong with it. It could be that you have weeds. It could be that you have a pest. It could be that that area wasn't fertilized enough. It could be that you didn't water that area enough, or there's soil, like it's a sandy part of the field and the water drains very quickly. You know, that's where knowing something about your field and the growers that I've talked to generally have, like, you show them an image of their field and you see an area that's not that healthy, they're able to pretty quickly say, oh, that part of the field never grew well because of X, Y, Z. I mean, they get that pretty innately. So yes, you can use that to approximate. I mean, the vegetation indices are just telling you where things are healthy or less healthy. Determining the exact cause of that, now that takes some more investigation and interrogation of your data.
Thank you, Amanda. Is the high-resolution Airbus DEM 10 meter free for users of the SRTM one?
So the answer to that is, if the customer, or if this person is asking about the World DEM, it is a 12-meter post spacing. It is not free. It's something, if they're asking about a government application, I'd say email me, we can talk more about it, and we can provide some sample data of the World DEM. We have some other geo-elevation products that are available as well that are higher resolution, anywhere from 1 meter to 8 meter on the optical side. So there are definitely a lot of options when it comes to DEMs through Airbus, and I'd be happy to talk about that offline.
Great. Next question. Do you supply quantitative data for the fertilization, such as prescription maps, or do you rather supply just the maps of the spatial variability over the field, of VIs over the?
Yeah, okay. So basically you could use that hotspot analysis to provide a prescription. Typically the prescriptions that I've seen have had other inputs that went into them, such as how much water was supplied to the field in previous years, the yield over previous years, because, I mean, farming has gotten so smart that you can have a harvester know exactly where, you know, how much was harvested in a certain area. So if it's harvesting and it goes, oh, I collected less corn here, that's an important input into your overall prescription. So this is a piece of the puzzle. I wouldn't necessarily say take that shapefile and load it up to your Caterpillar spreader and spray on that. You could, but I think there's other pieces of information that can help make a smarter output there.
Great. Next question. Can precision agriculture, I guess the toolkit, be deployed to map invasive weeds?
You know, yes and no. So that example that I showed with, let me actually go up to it. So with this vineyard here, in a vineyard, I wouldn't expect to have something growing between rows. If there is something growing between rows, that's probably a weed. And so you might want to have somebody go out and spray it, pull it, do something about it. Could I tell you what that weed is from this data? No. Could some other system do that? Perhaps. I think there's some really interesting work being done in artificial intelligence and machine learning with high enough resolution data, but it would take a lot of information to know exactly what a specific weed infestation would look like and how to follow that.
I agree with what Amanda just said, and I think ideally in that situation you would want to use hyperspectral data if available, because with that you could just obviously identify the signature and really quickly identify the exact weed you're looking for. But that's obviously, it's for certain customers not cost effective, and in certain areas of the world not available. So it can be a great solution if it's affordable and if you're talking about something on a small scale.
Yeah, just to add on to that, so yeah, if you're working with like a really high value crop, like let's say you're a wine grower, where your yield is really, really important, then high-res hyperspectral data probably could make economic sense. If you're a corn grower or some other commodity, probably doesn't, just because the cost per acre to grow it is so low.
That's a good point. Thank you.
And while you're flipping slides, someone wanted to a reminder of the email that they should send their shapefile.
Yeah, I will get there. There you go.
Great. For Airbus images of one field from different years, is there any displacement expected to overlap these images? And if yes, how do you adjust for that?
Well, if the customer is just ordering a standard ortho product from Airbus, there absolutely could be some displacement, and this is where having the ability to process within the Harris toolkit can, as Amanda already addressed earlier, can allow customers to adjust their ortho rectification and ortho products so that they will overlay correctly and there will be no displacement or as minimal displacement as possible. With any satellite imagery, you can have displacement until you actually go into a more advanced ortho rectification process.
Does Airbus have a plan to add a hyperspectral sensor on a satellite?
I can't answer that at this time because, frankly, I don't have any information about it. I think that is always a possibility. Airbus Defense and Space builds satellites, obviously, within our satellite group, and also SSTL is an Airbus company. So within those two satellite groups, there absolutely is the capability to build a hyperspectral system. Whether a government will order one or whether a commercial client, potentially a large agribusiness, would want to buy a hyperspectral satellite constellation and whether that would be affordable is another question. So I guess we'll have to wait and see on that. We definitely have had some customers ask us recently if that type of capability is coming, but I just can't answer that right now. I just don't know.
And just to add on to that, you know, it's not just Airbus. The only hyperspectral sensor that I'm aware of, and obviously there's probably super secret government systems, is basically the NASA Hesperi program, and that's to put an Avarice-like sensor in space. That's still in a scoping phase to my knowledge. So they're still flying Avarice test flights for that, and I'm not aware that NASA has actually funded a budget line item to actually fund the program. But if they did, that would be an amazing, I come from a hyperspectral background, I would love to see that. But I'm not aware of any commercial systems that would be going up right now.
All right, thank you. Next question. Is satellite data from Airbus available worldwide or in certain areas of the world?
It's absolutely worldwide. We have the capability to collect anywhere in the world. That's the great thing about our system. It's a sun-synchronous polar orbiting system with all the satellites. So you can collect anywhere from Antarctica, Mount Everest, I mean, you name it. Obviously, there's not going to be a lot of agriculture in those locations, but anywhere in the world, doesn't matter, we can collect. And if you have interest in terms of speaking with us and kind of learning more about the type of frequency we can achieve, all you have to do is email me a shapefile and we can take a look at that and run a feasibility report, and then we can give you some intelligence regarding this is the type of frequency we think we could achieve for this area. If it's something like the Central Valley of California, it's very easy to monitor. If you're talking about an area in Colombia with very high cloud cover, it can be a little bit more challenging, and that's where we ask customers to come to us, just give us a shapefile and as much information as possible about what they're trying to achieve, and then we can tell you with pretty high confidence from our experience with tasking that we can collect this weekly, we can collect this daily, etc.
Great, thank you, Sky. Can any of the processed results from ENVI be imported into a GIS like ArcGIS?
Absolutely. We have a very close relationship with Esri, and we're integrated really at the file, desktop, and interface level. So you can right-click on an image in ENVI and send it to ArcGIS Desktop. We can consume Esri image services. There's a lot of different ways to interact with that, and obviously, something like a QGIS, supports fairly standard files. ENVI's always been really good about, playing with other packages in terms of file and data support. So I think that's a natural progression would be to take this type of information into your GIS and have it be a component of the other data that you have.
Great, thank you, Amanda. Next question, can I have vector data besides the raster images as an outcome of the analysis to later publish them as REST services?
I'm sorry, Kevin, can you say that again? Or actually, I can see it here. Here we
Yeah,
go.
REST, or what was the last part?
Can I have vector data besides the raster images as an outcome of the analysis so that they can later be published as REST services?
Yes.
Oh, I see. Yep.
Yeah, so you could either do that with basically the output of the plant finder is a classification image, and there's classification to shapefile option, and then the vegetation indices you can threshold into various classes. So you could say from point 1 to point 2 is one class, point 2 to point 3 is another class, and then basically create a shapefile from that. And that's really easy in the ENVI interface. It's just a right-click. So yeah, there's a lot of different ways to get your data to a vector file, get the results to that.
Wonderful. Well, I think in the essence of time, we have a lot more questions coming in, and we could stay online all day, but we're going to cut it off here. So I'd like to thank all of our attendees for dialing in today, and also thank both Sky and Amanda for their great presentations and for sticking around to answer questions. On the screen is the email address if you are lucky enough to be one of the first 20 people that want to receive an additional analysis. Otherwise, you've seen Sky and Amanda's email addresses. You can feel free to ask them questions. So with that, I think we'll stop here. Thank you all very much.
Thank you.
Yeah, thanks everyone.